Welcome back to the series. This one's a quiet game changer. Earlier, we walked through Ollama's native API, and that's great when you're building from scratch. But the real unlock is this. Ollama also speaks OpenAI. Every tool you already use, LangChain, Cursor, Continue, LiteLLM, Aider, that crusty Python script from last year, they all just want a base URL, change one environment variable, point them at localhost, and suddenly your entire stack runs locally for free with zero rewrites. So why does this compatibility actually matter? OpenAI's API has quietly become the lingua franca of LLM tooling. Speak it, and you inherit the entire ecosystem for free. That means hundreds of libraries work out of the box, prototypes built against the cloud migrate to local in about a minute, and you can route hard queries to GPT-4 while sending cheap volume to Llama 3.1.8b through something like LiteLLM. And when a better model drops next month, same interface, same code, easy swap. Here's the key thing to understand. Ollama runs both APIs side by side against the exact same models. The native JIG API endpoints, generate, chat, embeddings, pull, show, are what we've been using throughout parts 5 to 18, and they're your gateway to Ollama-specific features like model files. The V1 Chopper endpoints mirror OpenAI's surface, chat completions, embeddings, models. Same Llama 3.1.8b underneath, two different doors. You pick whichever one matches the tool you're wiring up. So let's prove it works in about 5 seconds. Point curl at localhost port 11.4.34, but instead of hi API chat, hit V1 chat completions, and notice the body is pure OpenAI, a model field, a messages array with role and content. What comes back is the response shape you already know by heart. NED prefixed chat-CMPL, a choices array, a usage block with prompt and completion tokens. If you've ever parsed an OpenAI response, your existing code handles this without a single change. Curl is nice for proving a point, but real code uses the SDK, and here's where it gets almost suspiciously easy. Install the official OpenAI package, instantiate the client with two tiny tweaks, base URL pointing at localhost 11.4.34/v1, and an API key that just needs to be non-empty. Ollama is fine. From there, client.chat.completions.create looks identical to your cloud code. The only meaningful change is the model string. GPT-4o becomes Llama 3.1.8b, and you're running locally. And once the SDK works, the entire ecosystem built on top of it works too. LangChain and LangGraph pass base RL to chat OpenAI, and every chain, every agent, every example notebook from the docs runs locally. Continue and Cursor turn into private IDE assistants with a config tweak. LiteLLM lets you proxy and mix providers per model. Aider becomes a pair programmer over your local Llama 3.1. One environment variable, OpenAI base. URL, and a whole shelf of tools quietly switches over. Streaming works exactly the same way it does against OpenAI. Same server-sent events protocol, same delta shape on each chunk. The only change to a normal call is stream true, then you iterate and pull chunk choices, demide, delta.content as tokens arrive. On Llama 3.18b running on CPU, you're looking at roughly half a second to first token, which feels surprisingly responsive once you see it painting onto the terminal. Embeddings get the same treatment. The V1 more embeddings endpoint is right there, and the SDK call is identical. You just swap text embedding ADA02 for something like nomic embed text, and you're done. One catch worth flagging, ADA02 returns 1536 dimensions. Nomic embed text returns 768, so switching providers means re-embedding your whole vector database. If you followed the RAG builds back in parts 11 through 15, you're already on a Llama embedding, so this is genuinely drop-in. Now, the compatibility bridge is wide, but it's not seamless. There are 5 edges worth knowing about. Vision works on some models like Lava and Qwen2 VL, but coverage is partial, so test before you commit. Audio transcription isn't exposed at all, For whisper-style work, drop down to faster whisper from part 18. Image generation simply isn't Ollama's job. Reach for comfy UI or SDXL instead. Tool calling is mostly fine, with occasional quirks around exotic tool choice values, and token counts come back, but they're approximate. Fine for logging, not for billing. Now here's where things get fun. Once you understand the protocol, you can run it in reverse. Take that tuned RAG pipeline from part 15, wrap it in a FastAPI route at V1 or chat completions, and shape the response to match OpenAI's schema. That's it. Suddenly, Cursor, Aider, LangChain, anything that speaks OpenAI, is calling your custom RAG, thinking it's just another model. The bridge runs both ways. Now, before you go pointing this at the open internet, a word of caution. Ollama ships with 0 authentication, so anything that can reach port 114034 can use your GPU. The fix is small but important. Put Caddy in front, check for a bearer token in the authorization header, and reject anything without it. You get HTTPS, auth, and a clean reverse proxy in about 6 lines. On the client side, nothing changes except adding your API key, which is exactly how the OpenAI SDK already wants to behave. So with auth out of the way, here are 4 concrete things you can actually wire up tonight, each one a 15 to 30-minute job. Take an old GPT 3.5 turbo script and just swap the based upper URL to watch it run on Llama 3.1 for free. Wrap the RAG pipeline from part 15 in that little FastAPI shim so any OpenAI client can hit it. Point your VS Code Continue extension at Ollama for fully local code completion, and install LiteLLM as a smart router. Simple prompts go local, complex ones spill over to the cloud. Stack all 4 and the entire OpenAI ecosystem is quietly running on your own machine. Before you start swapping URLs, let me save you an afternoon of debugging. 5 traps catch almost everyone. Forget the AV1 suffix and you'll get a cryptic 404, leave API key empty and the SDK refuses to even send the request. Pass any placeholder string and it's happy. Model names must match Ollama list exactly. Watch the context window on older models and treat JSON mode as best effort. Validate with Pydantic if your schema actually matters. So let's pull the threads together. Ollama speaks OpenAI fluently, same endpoints, same SDK, same JSON, and migrating most code is genuinely just a base URL swap and a dummy key. The real prize is the ecosystem you inherit for free, LangChain, Cursor, LiteLLM, Aider, all suddenly driving your local model, and the door swings both ways. Wrap your own FastAPI in V1.0 chat completions, and any OpenAI client becomes a front end for your custom RAG. Just don't ship it without Caddy and a bearer token in front. And here's the page worth bookmarking. 12 things that between them cover about 90% of what you'll actually type. The base URL on port 114034 with the v1 suffix, a dummy API key, the 3 endpoints you'll hit daily, chat completions, embeddings, and models, plus the streaming shape with choices, Shakit Delta. And on the right, the escape hatches, LiteLLM when you need multi-provider routing, FastAPI when you need to be the server, and Caddy with a bearer token the moment anything leaves localhost. Save it and we'll wrap up on the next slide. That's part 19 in the bag. The bridge is online and your local stack now speaks fluent OpenAI. Next up, we tackle the thing that separates a clever API call from an actual assistant, memory. We'll wire up SQLite for conversation history, layer in summaries so context windows don't explode, and add retrieval so your model remembers who the user is across sessions. 19 down, 5 to go. See you in part 20.